Good afternoon. We'll talk about how to construct natural language database interfaces based on natural language models. Traditional natural language interfaces for databases, they range from keyword-based systems, systems that can handle natural language sentences whose semantics depend only on the semantics of the terms. For example, the sentence "was Liz Taylor married to Richard Burton" is equivalent to the keyword query with three keywords: Liz Taylor, married, and Richard Burton. On the other side of the spectrum, you have natural language database interfaces that are based on manually designed rules, which are complicated, but they can handle questions such as who had the same partners as Liz Taylor. This simple question is actually quite difficult to translate even directly to SQL. You also find in the literature a lot of papers on what is called open domain question answer interfaces. They are designed using neural networks and embedding models for the natural language sentences, but they can handle only typically very simple sentences. They are difficult to train, and they do not generalize. If they're trained for one data set, if you move the model to another data set, probably it will perform poorly. You also find in the literature what we call chatbots or natural language database conversational interfaces. They receive sentences, questions in natural language. They produce answers in natural language, but the answer to one question depends on the context, on the previous questions and the previous answers. This is a quite interesting class of interfaces. On the other hand, you have the so-called large language models, which are language models typically based on a transformer architecture. They have a very large number of parameters, billions of parameters. They're trained on very large quantities of unlabeled text using self-supervised or semi-supervised learning. They became quite popular with the announcement of ChatGPT later last year that is able to generate high-quality textual answers among many other tasks. Examples of large language models are Lambda from Google, GPT 3.5, which is used in ChatGPT, Llama, which was developed by Meta, and the newer version of these models, GPT-4, which is used in ChatGPT Plus, the paid version of ChatGPT, Palm 2, which is used in Google's Bard, and Llama 2, which was developed by Meta and announced less than a month ago. So the question that we intend to address is how to design natural language database interfaces that are based on large language models. Such models may simplify the interpretation of the natural language queries, the generation of the natural language answers, and even control the user dialogue. This is not surprising because the LLMs have been trained to incorporate those questions, those tasks. Examples of such design would be to use ChatGPT to translate natural language to SQL queries, or you can use ChatGPT to extract keywords from natural language text. As an example, suppose that you pass some database schema as a context to ChatGPT. like the table employee, the table department, and the relationship between salary payment, employee, and the amount of money. And then you can ask the question, list the names of the departments which employed more than 10 employees in the last 3 months. If you pass that to ChatGPT, it will translate or generate the SQL query that you see on the slide. And this is a quite interesting compilation because it is correct and use some constructs of Postgres like current last interval 3 months. So the question is how to use a large language model to create a natural language database interface. And furthermore, how to fine-tune a large language model to follow instructions over a particular database. And naturally test how good these interfaces are. As for the first question, you can translate natural language into SQL by passing the relational schema as a context, as I said, and then ask the model to translate it to the natural language sentence into SQL, and then go about executing the translated query. The next talk will detail how this can be done. But the point is that the database must have a schema for this approach to work. And the schema and the natural language query must be written in the same terms. If they're not written in the same terms, the translation will obviously not work. So one idea would be to use a mediator with a mediated schema that user understands. Well, the mediated schema is what is in the database, but written in the language that the user uses. A second alternative would be to use a keyword search tool to play the role of the mediator. Then the task of the large language model will be to translate the text box, the natural language query, and into a list of keywords, which are then passed to the keyword search tool to generate the answer. This has been tested using the Mondial database and 27 queries. As I said, the next talk will detail the experiments, but the alternatives, the best alternative would be to use the keyword search tool with a prompt instructions how to use the tool to extract the keywords. The second question was how to fine-tune a large language model to follow instructions over a particular database. That is to say, to create a chat model using one large language model and the database as the source for the instructions to fine-tune the large language model. This has been actually tested in a number of experiments, Alpaca from people at Stanford, GPT for All, Dolly from Databricks, and so on. Dolly is Alpaca is particularly interesting because what they've done is to start with a few self-instruct tasks, like brainstorm a list of possible New Year's resolutions. That would be the instruction. And the expected output would be something like lose weight, exercise more, eat healthier. The interesting point is that they used ChatGPT to start with this 175 self-instruct seeds and create 52,000 examples. Like one example of a generated task would be brainstorming creative ideas for designing a conference room. And the output was incorporate flexible components such as movable walls and furniture. Those 52,000 instructions had to be cleaned up to avoid duplications and badly formed instructions. And then they fine-tuned the meta-llama 7B, that is the llama model with 7 billion parameters, and created Alpaca 7B, Alpaca based on llama 7B. And then they compared the Alpaca with ChatGPT to see how good Alpaca was. So in general, what you can do is to start with a number of databases or large language models, create a set of sample question prompts from the databases, expand that sets, perhaps using ChatGPT, curate the set to create a specific set of questions prompts, and then fine-tune the language model using that last set. The conversational interface will then be built on the fine-tuned chat model. So to conclude, at this point, what we intend to do is to extend the experiments to test natural language translation into SQL, and the strategy of doing keyword extraction, perhaps using the benchmarks developed by the question and answer linked data challenges or any other natural language benchmark. And the second point would be to test how good the fine-tuning large language model to follow instructions over a database can be, perhaps using some modified large language model. And that concludes the talk. The next talk will go into details that I just skipped here. Thank you.